Right, in this video, we are going to take a look at why we want to use Apache Maven at all. So right now, depending on the survey, I got a little squiggly in there, Maven has about 70% of the build tool market for Java applications. And I say roughly, sometimes you see 68, 65, sometimes 75. It depends on who did the poll and the size of the audience that they surveyed. So you see it float around between 65 to 75%. Same goes for Gradle. They've been floating around 20%. And then 10% of people are still using Ant out there. And I am not a big fan of Ant by any means. So you'll hear me pick on Ant a little bit. Maven itself is very, very common in large companies. Companies with large development teams seem to gravitate towards Maven. Smaller companies where people are a little more adventurous, you'll see Gradle used more often. And this is kind of just my own personal observations. Overall, Maven is by far the most common thing that you're going to encounter in the workplace as far as build tools for Java projects. Now, back in 2002, Maven was started, and about 2 years later in 2004, it was moved to become a top-level project for Apache. Now, since then, all major IDEs support it, so you'll know that I use it. IntelliJ, Eclipse supports it, NetBeans supports it, just about everything supports Maven right out of the box because it is so popular and so widely used. Now, it is also commonly used by large open source projects. So if you look at Spring Framework, Spring Boot, Spring Cloud, Spring Contract, I think the Spring Data JPA guys are using it. So a lot of the Spring projects use Maven. So it's very, very popular for large scale open source projects because it is very, very stable and very robust. Now, the one thing I like to say about Maven is that it's so stable, it is boring. So I kind of laugh about that. And this little kid here kind of cracks me up too, because that's kind of how I feel about Maven on some days, because it has been so stable. A lot of times you only see releases maybe once or twice a year because it is such a stable code base. Nothing's really going on with it. It is mature. It's out there. Everything that can be developed as far as build tool has been developed. So there's not a lot of features and functionality missing from it. It's just a very, very stable tool. Now, some of the advantages of Maven. You have quick project setup. Maven largely brings convention over configuration that really reduces your startup time. So I can't stress that enough. You can get ready-made Maven projects very quickly, especially using archetypes. We'll explain that later in the course. The projects are modular, so you have very modular courses, very easy to set up. Very small projects, very targeted project modules. Maven makes this very, very easy to do. It also, going back to maturity, dependency management, it is very mature at that. I've recently been involved in some Node.js projects, and some of the dependency management in the JavaScript community is just a nightmare compared to Maven. So you get a lot of weirdness happening there. The project lifecycle, it's been around for a long time. It's been thought out. And it's one of those things that just works, that it has a very solid, a very well-known project build lifecycle, something that just absolutely works. And then we are going to be looking at a lot of the standard Maven plugins, but there's a lot of small projects, a number of projects that actually provide their own plugins for Maven. For example, Spring Boot. Spring Boot has a Maven plugin that provides features and functionality in the build process, and we'll look at this in the project. But that is just an example of one plugin that is not created by Apache Maven. That was actually created by the Spring team. So there's a lot of small plugins like that. If there's a project, popular Java project, and it's involved in the build process, chances are they're going to have a Maven plugin for that. So very, very, very common for third parties to extend Maven plugins and provide features and functionality targeted towards the Maven platform. Now, Maven has also become the de facto standard. And I'm saying Maven has established, and this is in air quotes, standards, because they're not like formally documented standards, but these are things that are widely used. The Maven standard directory layout, before that, there wasn't one. The standard directory layout, and we'll look at that in an upcoming lecture in the course, has largely been adopted by other tools such as Gradle. So now this Maven standard directory layout has become a standard of how you do Java projects. Artifact naming. Maven helped establish how Java artifacts are named in repositories, and also artifact repositories themselves. Maven helped establish the structure of artifact repositories. Now, prior to these air quote standards, they didn't exist. And this is very problematic. I remember doing Java development before Maven, before it was widely adapted, when you're using Apache, and there were really no standards. And every project team did it a little bit different. They'd all name things differently. So it was kind of free for all. And there were no standards. There wasn't anything there. So as you move from project to project, everything was different. So Maven brought a lot of standardization to the table. So one of the things that really helped the Java community as Java matured into the enterprise, this is very, very important. And now we're seeing a new generation of build tools such as Gradle. They are compatible with these standards. You have Ivy that is used for dependency resolution that now adheres to some of the Maven standards, or at least is compatible with Maven standards. Now, Maven is not without its criticisms. Projects are described in an XML document, the Maven POM. This is constrained by an XML schema. So basically, you have a structured document that describes your build. Good thing overall, very, very good thing. Some people consider XML dated, but this document is basically a description of your build. Effectively, it's kind of more or less static. With some exceptions, it is static. On the other hand, Gradle uses a Groovy DSL, which does offer you a lot of build flexibility when you have complex needs. Because you're not using a document, you're actually using Groovy DSL. You also get the full power of the Groovy programming language and the scripting language capabilities of Groovy. So you can do a lot of really cool stuff with Gradle. It does give you a lot of flexibility. When you get into this area, this is probably the 10% of builds that you're going to need this, probably even less than 10%. Sometimes you need to take a step back and say, do I really need to do this? You can do a lot of really cool things with Gradle, and I have done some pretty interesting things with Gradle and seen a lot of interesting things done with it. But these are edge cases, definitely edge cases, when you need that greater flexibility of having the Groovy programming language to describe your builds. Generally, Maven is so mature, someplace, someone's already run across a problem that you have, and there's either a way to do it or there's a plugin that will help you do that. So a lot of times when you're hitting these build problems, you're not the first person to hit that, and it's already been solved somehow in Maven. So while Gradle does offer greater build flexibility, it's kind of rare that flexibility is actually needed. And that's not to knock Gradle at all. I use Gradle quite a bit myself. I actually go back and forth between Maven and Gradle. So it is not a dig on Gradle. This course is specifically on Apache Maven, so we'll be looking at Maven closer. A lot more to come in the course. We'll be diving down deep into the features and functionality in Maven in upcoming lectures.